this computer. Okay, so I uploaded the videos already, and today we are going to discuss the last lecture topic for this class. Next week we are going to make the lecture time as a review time for the final exams. So today we're going to cover the last topic that will be included in your long test 2. So I dedicate this time to take an exercise of full space control and using the Jacobian and using the controller that we discussed last meeting that we didn't have time to take an example. Okay, so now let me do that to make an example. I will take the example that we have, one of the robots that we have in the lecture, so that it will be easier for us to see what's going on. So here I dedicate this space for us to write something. And here are some of the information. This is the algorithm that we need to follow. Okay, so let's make this. I hope you can see that. So this is the algorithm for the planar robot, but we use exactly the same algorithm for the full space robot. The only difference is that the Jacobian is not analytically derived, but we are going to geometrically derive, just like what we discussed last meeting. Okay, here we'll put the Jacobian here, and here this will be where we are going to write. Okay, so first we are going to make use of, just for the sake of discussion, we're going to make use of this spherical robot, spherical wrist. Okay, so never mind, we'll just use the index here, 4, 5, and 6. It doesn't matter. Okay, so what matters here is that we are going to implement this algorithm, that we are going to derive the Jacobian matrix and then use this Jacobian in order to come out with the step control. The step control, okay, this is the Q. We can initialize to some value Q of where the robot is currently. And then from these current angles, we will step towards the new angle where we are going to use in order to go to the desired X value. Okay, and then this one will be a loop until, for example, we say until 3 steps or 4 steps, or if it is a computer program, until the error term of the position as well as the orientation will be minimal. Okay, so now let's make use of the spherical wrist and compute first the Jacobian. So now this is Jacobian, and so we write the Jacobian. How many joints is the spherical wrist? How many joints is that? Anyone? How many joints? Can you see this? Can you see what I'm writing? Okay, joints is, of course, 3. Okay, so that means your Jacobian will be, okay, we'll just write down here. Okay, we'll make use of the full Jacobian because we have enough time. 0, Z0 cross with 0, P6. Okay, now it will, okay, let's just do 0, P3. Okay, we'll change the thing here. 1, 2, and 3. We'll change the indexing here so that we won't be confused. Okay, so this is theta 1, theta 2, and theta 3. Okay, and this one is D3. Okay, so anything else here will be A, okay, 0, 1, 0, sorry, undo, 1, A2, and then 2, A3. Okay. And then here, the index will be 1. The index here will be 2. And the index here will be 3. Okay. Just so we won't have a problem with the indexing of the Jacobian. So now 0Z1, 0Z0 cross with 0P3. So 0Z0. Okay. Next. 0Z1 cross with 0R1, 1P6. 0Z1.
Sir,
Yes. Sorry.
it's 1P3.
Yeah. Thank you. Okay. The next 0Z2 cross with 0R2 and then 2P3. 0Z2. Okay. There. So these are our 3 columns. So where can we get 0Z0? So 0Z0 is just equal to 0, 0, 1. Okay. And this one is also equal to 0, 0, 1. There. What is 0P3? Well, 0P3 is here. I want to make it this one. Okay. So, okay, there. Let's go back to annotate. Then let me erase some here because it's confusing. Okay, let me write again so that we won't get confused. So this is 0A1, 1A2, 2A3. Okay, and the index here is 1, index is 2, index is 3. Okay, and this is 0A3. Okay, from the base, okay, if we use this one as our base, this is frame 0. Oh, there's no distance here. The frame 0 should be somewhere here. Okay, this one is somewhere here because there's no distance. Okay, and then here, this is frame 3. Okay, let's not worry about this. Let's just take the DH parameters as they are given to us. Okay, so this is link 1, 2, and 3. And then the variables again, we have theta 1, theta 2, and theta 3. And then this is D3. Okay, so now your 0P3. So this is 0A3, right? So we know that for 0A3, this is your 0R3. Okay. And what is your 0P3? This is the one, 0P3. There you go. Okay. So 0P3, you substitute here. Okay. So this is C1, S2, D3. S1, S2, D3, and C2, D3. Okay, I have to be careful so that we don't. Okay, you understand this? So we're done with the first column. So how do we compute the cross product? How do we compute the cross product? Okay, so when A cross B, for example, how do we compute that? So there's another method to do A cross B that I use normally. So instead of crossing, I make this as a matrix. So A cross, I make it S of A. Okay, that will make a matrix multiplied by B. But what is S of A? So S of A is a skew symmetric matrix that is equal to, let me check this. Okay, 0, 0, 0. Okay, and A2, A1, A3. Okay, I think this one is negative. A2, A1, negative, A3. Let me check first for a skew symmetric matrix. Let me check in my, I cannot. Yes. Let me check. Go to my paper. Just to think that because I don't memorize things here. So this one, so there's something wrong. It should be, okay. Z, where is the annotation? I should learn it by heart. Not 2 here, but 3. So this is 3. This is 2. That one is 1. Okay. So the third component, second component, and the first component, and the signs are correct. So in this case, this again is the third component, the second component of the vector A. This is A, and these are the components of that vector. And then we okay. So let's just use this so that for easy computation, we don't need to do the quite difficult process of cross multiplication. So let's just, so this is now your S. So in this case here, we say that to do this, so 0 Z0 cross multiply of 0 P3 will be equal to skew symmetric matrix S, where your input is 0 Z0, okay, multiplied by 0 P3. So if you can see, S, the output is a matrix, okay? So now we can put the matrix here, multiplied by 0 P3. So 0 P3 is C1, S2, D3, S1, S2, D3, C2, D3. Okay. So now, what is your 0? So here are all 0, yeah? So this one is only 1 on the third on the third parameter, on the third component. So the third component is here. So here is 1, and that's negative, and here is 1. Okay, that's all. And the rest will be 0. Okay, so now what is 0p3 in this case? So 0p3 will be equal to what? Okay, let's compute. So what this one plus this one. So minus this one and 0. So this is minus S1, S2, D3. You get it? Okay, next row, this one plus 0 plus 0. So this one, now this is C1, S2, D3. Okay, the next 0, 0, 0. There's nothing, so 0. There. That is, okay, sorry, this is not 0p3, but this is that one. This multiplication, the result of this one equal to this one. Okay, this is not 0p3. Should erase that. Okay, so now let's write somewhere. Now our Jacobian, we have a Jacobian here. Let's just write a Jacobian. So the first column we have already computed, minus S1, S2, D3, C1, S2, D3, and 0. Then the next, there's the position part, and then 0, 0, 1. Okay, now we have the first column. Okay, then now we compute the next column. So this is the position part, the top three, the top three components are the position part, and the last three components are the orientation part. Okay, now let's continue. So what is 0, 0, Z1? Okay, so now let's remove now. Okay, this one, let's remove our computation here because we're done with this one. Now we are going to do the next column. Okay, let's start with 0, Z1. What is 0, Z1? Okay, so 0, Z1 is, do you know, okay, first, do you know how we get this? 0, Z0? Do you know how you get this? It is frame 0 with respect to frame 0. Frame 0 with respect to itself. How do we know this? Well, first of all, we can take that 0A0. What is the rotation of 0R0 and the position of 0P0? What is that? Well, the rotation, of course, there's no rotation with respect to itself. So that is an identity matrix. 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? And then this one, 0, 0, 0. What is the position? There's not, it doesn't move with respect to itself. That's all 0. And this is 1. Okay? So we know that the rotation matrix is this part. And the position is this part. Okay? And we only take the 0, Z0. So we know that, what is this? 0, X0, 0, Y0, and 0, Z0. Okay? This part here. Any questions? Okay. Now, let's go to any questions? No? Okay. Let's continue to the 0, Z1. Okay. How do you compute for 0? Oh, there's something wrong here. Nobody corrected me. This one is not Z0, but 0, Z2. Okay. Okay. So how do we know? Okay, let's erase again because so that you can see it clearly. So we are done with the first column. Now we want to do the second column. So first, let's just do the first easy thing. This one, 0, Z1. So what is 0, Z1? So again, we write down 0, A1. And then we extract 0. This is the one. 0, A1. That is the one. So we write down C1, S1, 0, 0. Then 0, 0, minus 1 and 0 minus S1, C1 and 0 and 0. Okay, 0, 0, 0, 1. There's no position translation there. So now, again, this is your rotation. This is your 0, R1. Okay, this is your 0, R1. And this is your 0, E1. Okay, so this part is what? 0, X1. This part is 0, Y1. And this part is 0, Z1. Okay, so that's why you have this part. Okay, so now if you do that, you have 0, Z1 is minus S1. Okay, sorry. Let's use the green color. Okay, so this part here is, okay, let's go here. So that is 0, Z1 is minus S1, C1, 0, cross with, what is 0, R1? 0, R1 is this. C1, S1, 0, 0, 0, minus 1, minus S1, C1, 0, multiplied by 1P3. What is 1P3? What is 1P3? So now we need to compute from here. So you have, okay, manually it is really very tedious, but we have to do it. Okay, let me write down this note here for S of A so that we don't forget. I can delete that. 0, 0, 0 minus A3, A2 minus A1 and A3 minus A2, A1. Okay, now we can delete the rest of this one. Okay, let's compute the 0P1. So 0P1, can you see the green color? It's not difficult to see. So 0P1, I mean 1P3 can be derived by A1A3. Okay, 1A3 is equal to, okay, 1A2 times 2A3. Okay, what is 1A2? There. C1 S1 0 0 0 0 minus 1 0 minus S1 C1 0 0 0 0 0 1. Next. Okay, this part. C5, no, not C5, but what is this? C2 S2 0 0 0 0 1 0 S2 minus C2 0 0 0 0 0 1. Okay, what do you think? What do you think from here? You can derive, can easily deduce. Here, there's no translation, yeah? Here also, there's no translation. Okay? So that means the result of this will be purely rotation. There's no translation. Most likely, I mean, the position will also be 0. The 1P3. Because the result of this one will be, what is the result of this one? The result of this computation will be a rotation part 1R3 and a position part 1P3. Okay, we are only interested in taking the 1P3 part. Okay, so we can compute this one directly to look for 1P3. Compute. Okay, anyway, so we will only concentrate on the result of the this part. We don't, okay, let's not compute the rotation. We only compute the position part. Okay, so how do we do this? Which part we will be computing? If you can only compute the position part, okay, so that means we consider this one and this one, right? It will be this part. Yes. And this one multiplied by this one, it will be this part. This row multiplied by this column, it will be this part, right? Correct? How do we get this result? How do we get this computation? It is the whole row, this row, because this one is what? 1, 4, right? The index there is A of 1, comma 4. That means first row and fourth column. So first row multiplied by fourth column. Okay, so if you say C1 times 0 plus 0 times 0, S1 plus S1 times 0. Oh, sorry, the whole thing here. Okay, so C1 times 0 plus 0 times 0 minus S1 times 0 plus 0 times 1. So this one is 0. That is 0. Next, the same thing, we compute second row and same column. So again, that is 0. And third row, the last column, third row and the last column, again, that's 0. Do you understand? Okay, so your 0, your 1p3 here is 0, 0, 0, 0. There. Okay, what's the result? One P3 does not move. Only 0P3 moves. 0P3 is this one. But 1P3 did not move. Is that correct?
So, your 283, I think it might be wrong.
Yes. Yes, it's true. It is wrong. Even the 1A2 is wrong. I took this matrix and this matrix, which is wrong. I should take this, this, and this.
Yes, sir.
Yeah. Did everyone agree? I took the wrong matrix. Okay. Okay, let's do it again. The nice thing about committing mistake is that we understand better, but the work is more. But anyway, let's do it one more time. Did you agree? If you didn't see it, it's just wrong in the substitution. So 1A2 is this one. 1A2 is that. So we have C2 S2 0 0 0 0 1 0 S2 minus C2 0 0 0 0 0 1. Okay, the next 2A3. 2A3 is this one. So you have C3 S3 0 0 minus S3 C3 0 0 0 0 1 0 0 0 D3 and 1. Okay, now let's compute again. We have to consider the row and the column. So this one is better. So this row, okay, against this column. Okay, so what is that? What is that? We'll just compute the P1, P3 only, okay? 1, P3. So if you only take 1, P3, so we only consider that first row and fourth column. So C2 times 0 plus 0 times 0 plus S2 times D3, okay? Plus 0 times 1. So this is S2 times D3. This is S2 D3. Okay, so next, let's again, the next row. Let's go to the next row. And I want the blue. Okay, next row, this one. And the same column. Okay, so what's that? So S2 times 0 plus 0 times 0 plus minus C2 times D3. okay, plus 0 times 1. So the only one that matters is minus C2 times D3. So minus A. Minus C2 times D3. Okay, then next we go to the last row and the last column, I mean the third row and the last column. So it's 0 times 0 plus 1 times 0, again that's 0, plus 0 times D3, that's 0. I mean, again 0 times 1. I didn't include this. Anyway, I should make it the last. I want to show this one. Okay. So in this case, the computation there is 0. Do you agree? 1P3. So here, this is wrong. Okay. So now we will write down the correct one now. S2. Write the correct one. S2 D3 minus C2 D3 and 0. Okay. So now let's compute this one. What's the result? Before we go there. So let's just leave this one. We cross with, okay. The result of this one will be a vector, right? Okay. So C1 times S2 D3, okay, plus 0 times this one plus this one times 0. So only the first part remains. So this is C1 S2 D3. Okay. Next, S1 times S2 D3 plus 0 plus 0. So this is S1 times S2 D3. Okay. The last row, 0 times this one becomes positive C2 D3. So C2 D3. Okay, then that's it. Okay, so let's go down there. So what's the final answer? So let's remove this. Okay, so this one will remove. We will show the result of, okay, tell me when it's 12 o'clock so that we can have a break. 0 Z1 cross with 0 R1 1 P3 is equal to this one now minus S1 C1 0 cross with another vector C1 S2 D3 S1 S2 D3 C2 D3. Okay, so now if we do our matrix computation with the cross product, so it will be 0 0 0, and the first is the third element, negative of the third element is 0, so that's 0 and 0. Okay, whereas the second element is C1, so this is C1 here and minus C1 here, and the first element is minus S1. So the negative of the first element. So here is S1, the negative of the negative S1. So that's S1. And then the negative, the positive of that. So that means this is minus S1. Okay, multiplied by C1 S2 D3 times S1 S2 D3 times C2 D3. Okay, is equal to, now we'll see what's the result here. So the result will be just a vector. So 0, 0 times this one. So this is C1, C2, D3. Okay, next 0, 0, and then S1. S1 times C2, D3. Next, this one. C1 times, so this is C1 squared, okay, plus S1 squared, okay, and 0. So in this case here, there's a negative sign. So that part here is minus C1 squared, okay, times S2 D3, okay, minus S1, the second, this one and that one, this one and this one, so minus S1 squared, S2 D3. Okay, so now that is your first, that is your the result here. So now we have our second column. Your second column is C1, C2, D3. Next is S1, C2, D3. And the third part, and the last one is this one that I have written here, minus C1 squared, S2, D3, minus S1 squared, S2, D3. Okay, so this is the position part. And then what is the orientation part? This 0, Z1. We know already 0, Z1 is this one. Yeah. So minus S1, C1, and 0. Okay, there. That is your second column. Any questions? This is squared. Okay, it's not clear. There. Okay, you have your second column, and then next we'll do your third column. Any questions on the second column? No questions? Okay, let's do your third column. It's going to be 12 o'clock. Okay, maybe I stop here so that we can look at the, no. I don't want to stop here because all these notes will be gone. Let's finish. Let's finish the third column and then I will write it down so that we will continue. Let's just finish the third column because otherwise all these notes will be gone. Okay, so let's make it fast. Any questions? So that's how it is. It's just purely substitution of all the terms and looking for how these terms are computed using the transformation matrices. So let's just remove this because we are done with that. Okay, now we are interested in that part. Okay, what is 0Z2? Okay, we start with 0Z2 because here 0Z2 will be the, here we don't have space. I'll put, where should I put the last J? Okay, maybe somewhere here. Okay, so 0Z2, we can compute it from 0A2. Okay, so we know that this is 0R2 and 0P2 and 0 and 1. Okay, so what is 0R2? So this one, 0A1 times 1A2. Okay, so what is that? 0A1 is that one, C1, S1, 0, 0, 0, 0, minus 1, 0, minus S1, C1, 0, 0, 0, 0, 0, 1. And then you have C2, S2, 0, 0, 0, 0, 1, 0, S2 minus C2, 0, 0, 0, 0, 0, 1. Okay, so what is the result? Let's just write it down. 0A2 is equal to, okay, so this is the part that I was telling. There is no position. It doesn't move in terms of position. So that's all 0. We'll be just writing the orientation, but we can verify it by computation. Okay, anyway, so the first part, this one, the first element is, okay, so this row and this column, so C1, this row and this column, C1 times C2, okay, plus 0 times S2 plus 0 times S1 times 0 plus 0 times 0. So the only alive element is C2 times C1. So that is C2, C1. Okay, next, S1, C2 plus 0 plus 0 plus 0. So S1, C2. Next, 0 minus S2, 0, 0. So minus S2, 0, 0, 0, 0. So this is 0. Next, C1 times 0, 0 times 0, minus S1 times 1 plus 0. So this is minus S1. Next, 0 times 0, I'm 0 times S1 times 0 plus 0 times 0 plus C1 times 1 plus 0. So this is C1. Next, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Next, C1 times S2, okay, C1 S2 plus 0 times C minus C2 plus minus S1 times 0 times. So the first, only the first element is alive, so that's C1 times S2. Next, S1 times S2 plus 0 plus 0 plus 0. So S1, S2. Next, 0 plus C2 minus 1 times minus C2. So plus C2 plus 0 plus 0. So that is C2. So 0 plus 0 plus 0 plus 0. That's 0. Okay, next. So C1 times 0 plus 0 plus 0 plus 0. So this is 0. S1 times 0 times 0 times 0 times 0, that is 0. 0 times 0, I mean 0 plus 0 plus 0 plus 0, 0. And then 0 plus 0 plus 0 plus 1. There you go. Okay, now that is your 0A2. So 0A2, so that means that your 0A2 here, okay, okay. This is your rotation matrix. So this is your 0, what we're looking at, 0Z2. Yeah, so 0Z2, this is correct now. Did I substitute correctly? 0Z2 is equal to this one. C1 S2 S1 S2 C2 and okay, that's 0Z2. Okay, now what is 0R2? So this is 0R2. 0R2. Okay, just copy that one. And what is your 2P3? Okay, 2P3 is this part here. We don't need to compute. This is 2P3. It's given. So 2P3 is equal to 0, 0, D6. Okay. So we already have this, and this one, so we can delete everything and we compute. So we delete. Okay. So where? Okay. So what is a 0R2 multiplied by 0P3? This is equal to C2 C1 minus S1 C1 S2 S1 C2 C1 S1 S2 minus S2 0 C2 and multiplied by 0, 0, no, not D6, but it should be D3. Okay, so now, so the result of this will be a vector. Okay, so 0, 0, so here that is C1, S2, D3. Next, 0 plus 0 plus this one, S1, S2, D3. Next, 0 plus 0 plus this one, C2, D3. Okay, so now we are ready to do this one, the cross multiplication. So let's okay, let's leave this because we need that. So now our result of 0 Z1 cross with 0 Z2 cross with 0 R2 2P3. Okay, so we use the S input with the input of that vector. So again, this is 0, that's 0, and that's 0. The third component, the negative of the third component minus C2. The second component, S1, S2. the negative of the first component minus C1 S2. Next, this is C2, so that is C2 here, positive. Okay, next, that is the negative of that one, S1, S2. Okay, and then the negative of the first, I mean, not the first component. This is S1, S2. The first component, C1, S2. Okay, multiplied by C1, S2, D3, S1, S2, D3, C2, D3. Any questions? So now we're going to take the vector result. So 0 times this one, C2 times that one plus this one. Okay, so that means minus C2 times the second, this one, S1, S2, D3. Okay, next is this one, S plus S1, S2, C2, D3. That's the first component. Okay, the second component is C2, C2, C1. Questions? S2. Are you seeing it or no? Plus 0 plus this one. So this is negative. Negative C1, S2, C2, D3. And then lastly, very long. Okay, the last part is minus S1, C1, and then S2 squared, D3, plus S1, C1, S1, C1, S1, C1 yeah, times S2 squared, D3. There you go. Okay, that's the third column. Now we're complete now. So because we know 0 is 2, so we can write down. Let's write down here the last column of the Jacobian so that it will be clear for you. Who's that breathing very heavily? Yeah. Okay. So how do I? Okay, let me write here. I want to write a new so that you can see it clearly. Okay, here, let's cover this because we don't need this anymore. Okay. And erase. Okay, let me finalize the Jacobian for you. The columns of the Jacobian of this is just a three joint robot, and we are considering position and orientation. So your Jacobian, let me write down everything. Your Jacobian will be, let's start from there so that you can see it clearly, minus S1, S2, D3, C1, S2, D3, 0, then okay, 0, 0, and 1. Okay, I'm just writing this separation so you can see it clearly. C1, C2, D3, S1, C2, D3. I thought they're giving me a stylus that will help me in this lecture, but that stylus is not helpful. C1, S2, D3, minus S1 squared, S2, D3. Okay, and this is the position. Position is minus S1, C1, and 0. Okay, so now the third column. Hello? What is it? Minus C2, S1, S2, D3. Hold on. It's not clear. S1 is very difficult to write. S1, where is it? S1, S2, D3 plus S1, S2, C2, D3. Next, C2, C1, S2, D3 minus C1, S2, C2, D3. Then the third term, S1, C1, S2 squared, D3 plus S1, C1, S2 squared, D3. Okay, then the next, what is 0, Z2? This is the one. C1, S2, S1, S2, C2. Okay, that is your Jacobian. Any questions? Now, with this Jacobian, we will be ready to implement this controller. Maybe let's just take, after this, we'll take 2 steps of computation so that you will know. Okay? Okay, let's stop here. Okay, let me take a photo so that I can record. We can have a discussion, good discussion after we come back. Okay, I'll stop the sharing. Any questions? If no questions, let's, who's this? Teaching by Tom Martin Timana has TV room today, 8 on this lesson. Oh, they will teach you. Oh, very good. Yeah, Camela should be there. You want Camela to be there? Okay, anyway, that's good effort. Yeah, it's good to have group discussions. And then you can also sit together closely. Maybe, you know, somehow Buaho will sit closely to Miss Horata, and something like that. Something can bloom out of the group discussions. Okay, okay. I'll give you 5 minutes and then we'll come back in 5 minutes. Thank you.